You tested the sound, right? Yeah. Okay.
Hi everyone, and welcome to the A Bit of AI Live from the Reactor in Redmond. Tonight we have a live audience, which is going to be awesome. We have lots of people in the stream, and we're going to have 3 awesome sessions. We will start with B, then we will move to Ruth, and then we close off with Dave. And at the end, we will do a live recording of the A Bit of AI panel, where we're going to find out what they are actually doing during their day and how they ended up in AI. So I'm going to give the stage to B, who is going to do a recap of her demo at Microsoft Build. So the stage is yours.
Thank you, Henk. Well, since we don't have a huge audience, I'd like to actually just start by asking you guys, like how much experience do you have with Azure ML, cognitive services, applied AI? Have you seen this slide before? Is this like totally obvious, or should I go over it?
I've seen it before, but I work here.
You don't count, David. Sorry, you don't count. Everybody else. I'll go over it very quickly. So basically, these are the offerings that Microsoft has in AI. And they're kind of like ordered from bottom to top based on like how much coding, machine learning coding, the developer is willing to do. And so at the very bottom, we see Azure Machine Learning, which is the product I work for, that helps developers who are developing, or data scientists who are developing the models from scratch. It helps them to run those models, to train those models in the cloud, and to deploy those models in the cloud. So typically, people are going to be working at this level if they're very familiar with machine learning code, if they're using PyTorch or TensorFlow or scikit-learn or any of those packages that kind of allow a lot of flexibility to work with models, to create new models. And at the next level, we have Azure Cognitive Services, which are kind of like prepackaged common machine learning solutions. So for example, vision is a very common thing. You know, we often have to like create a model that distinguishes A from B, like cats from dogs or something like that. And you could write that from scratch, absolutely. You know, it's something that anybody taking a machine learning class will do that once in their lives. But once you've done it once, you don't need to do it again, right? There are prepackaged solutions that enable you to do that. So you can just use our vision cognitive service and add a little bit of training on top of that, and you can distinguish cats from dogs. At the next level, we have applied AI services, which are services that are even more complex than Azure Cognitive Services. They typically include one or more, or 2 or more cognitive services, and they kind of integrate those together. And they offer a solution that is to a very common problem. For example, a form recognizer. You can scan a form that has like little spaces for people to fill out things and questions and check boxes and all that, and it can recognize that automatically by using a few different cognitive services. And then at the very top, we have, I think, the most interesting layer. I mean, I think it's almost like the magic layer, which enables people who don't actually necessarily know how to code to do amazing things with AI. Using Power BI or Power Apps or even Microsoft 365 and all that. And this is very interesting. And at first I didn't think this was very interesting when I started at Microsoft, but over time I've seen what the community has been building with these apps and people who could never imagine ever creating an app, and I'm just constantly blown away by what I see. So that's also, like, I think they're all interesting. So my area of focus is at the bottom, Azure Machine Learning. So the demo that you're going to see, it's going to focus on those features, Azure Machine Learning features. And specifically, it's going to focus on the announcements that we made at Build. So what you're going to see is the demo where we showed off our new announcements just a week ago. And then we're going to have Ruth and Dave, and they're going to be talking about other kind of layers here. You know, I think Ruth is going to be the decision cognitive service, right? I'm sure she'll tell you more about that. And Dave is going to be more on the applications, like the top layer. And so you're going to see some really interesting things. But I just kind of wanted to give you an overview so you know what you're going to see, like where it falls in the Microsoft stack. So I'm going to show you the demo. This is actually a slightly extended version of, and much, much better version compared to the build demo. And as I said, it shows off some of our features, and I'll talk a little bit at the end what those features are and why they're cool. But I'm going to show you that. Oh, and one of the reasons why I'm showing the video is because if I did this live, we would be here for over an hour, because it just takes so long to train and to deploy. So it's just not really feasible to do this live. That plus I'm lazy. And so we're going to watch the demo, and then you can ask questions and also talk a little bit about the features that you're going to see. All right, playing. My name is Stollnitz, and my goal for this demo is to show you how you can create a production-ready workflow using notebooks as a starting point. My name is Stollnitz, and my goal for this demo is to show you how you can create a production-ready workflow using notebooks as a starting point. And of course, I'm going to use Azure ML for that. My colleague handed me a couple of notebooks that take a trained GPT-2 model from Hugging Face and fine-tune it using books from the Greek poet Homer. I'm going to show you how to organize his code into components, how to connect those components into a pipeline that registers a model, and how to deploy that model using an endpoint. We'll take a look at how to create Azure ML resources using the Azure ML Studio UI, and I'll show you 3 ways to create resources using the CLI. From within the terminal, using a GitHub action, and using the Azure ML extension for VS Code. Let's dive right in. I added the books that my colleague gave me to my project. Notebooks are great for experimentation, but Python files will make it easier to refactor his code into components. So I went into each of his notebooks, clicked on Export, and saved the notebooks as files ending with the .py extension. Then I analyzed his code carefully and decided to separate it into 4 files. The model notebook turned into the Hugging Face and register model files, and the train notebook turned into the fine-tune and process files. Let's look at the process file. The purpose of his code is to read the data source and split it into training and validation sets. You can see here that it takes as argument the source folder for the dataset, a training validation split, and the paths where we want to save the training and validation outputs. Notice that I gave it some default values, so if I run it locally, I expect the original data to be under data Homer, and the validation and training data will be saved under data processed. Let's run this code. As you can see, a data process folder is generated as expected and contains the training and validation sets. Now that I have my code nicely refactored into separate Python files, I can create an Azure ML component for each of those files. An Azure ML component is really just a resource that encapsulates a reusable piece of code with inputs and outputs. I'm going to create resources using YAML files, like this process.yaml file, which, as you can see, contains the arguments that we saw in the code file. I have 2 inputs, a folder with a dataset and a training validation split, and 2 outputs, the paths to the training and validation sets. There's one more thing I need, an Azure ML environment that specifies all these dependencies that this code relies on. I already have a YAML file with the configuration for a good training environment, which I named base-hf transformer train. I just need to register it with Azure ML, which I'll do using the CLI with an azml environment create command. Now let's go to the studio and verify that our environment was created. And it was. Great. Now that I have an environment created in Azure ML, I can add it to the YAML file of each of my components. I could use a CLI command to create these components, but I would need to use 4 commands each time I make any change to these files, and that would be tedious. Well, I have a better way. I created a GitHub action that watches for changes to Python and YAML files within the components directory and executes the azml component create command. And the coolest thing about it is that it increases the version number of the component automatically. Let's see this action at work. I'm going to check in the changes to my 4 components. I'm going to make a pull request from my branch to main, merge into main, and the GitHub action kicks in. I'm going to speed up this bit so that we can focus on the interesting parts, and when it's done, we can go to Update Modified Components and see that the GitHub action detected changes to these 4 files and executed azml component create commands for each file. And we can see here that the fine-tuning component was registered with version 18. Let's confirm that these were created in the Azure ML Studio. Okay, here are the 4 components we created, and the fine-tuning component has version 18 as expected. Remember that one of the inputs expected by the process component is a folder containing the original data. Well, my data is on my local machine, so I need to create a dataset to make it accessible from the cloud. I could use an azml command for that, but let's use the UI this time. I'll go to Datasets, Create Dataset from Local Files. Let's call it Homer, and choose File for the dataset type. I'm going to click Next, then Browse to find the dataset folder, then click Upload, click Next, and then Create. This creates a new dataset. Let's verify that it contains the files we want. Yep, here they are. Now that I have the dataset and all the components registered in Azure ML, my goal is to connect them into a pipeline that fine-tunes a GPT-2 model with my dataset and registers the resulting model in Azure ML. I could create a pipeline using a YAML file in the CLI, but for this demo, I'm going to create this pipeline using the designer right in the studio. I'm going to select Compute Cluster. I'm going to pick a pretty fast cluster, and I'm going to give the pipeline a better name. You can see here on the left that I can add datasets and components to the pipeline. I'm going to start by dragging the Homer dataset, which I created earlier. Then I'm going to drag the 4 components you've already seen onto the canvas. This one splits the dataset into training and validation sets. This one gets the trained GPT-2 model from Hugging Face. This one fine-tunes the GPT-2 model, and this one registers a fine-tuned model with Azure ML. We get a little warning in 2 of our components. That's because they expect me to specify some inputs. For this component, I need to say that I want a pre-trained GPT-2 model from Hugging Face. And for this one, I need to specify a name for the output Azure ML model. Now let's connect them. The dataset returns a folder path which my processor component expects. The processor returns training and validation data which connect right into the fine-tuning component. The Hugging Face component returns weights, a tokenizer, and a config, which our fine-tuning component expects in that order. And the fine-tuning returns fine-tuned weights, a tokenizer, and a config, which the model registration expects. Now I just need to submit this pipeline. I'll choose the NLP tests experiment and submit. This takes a few minutes to run, so let's fast forward to the completed pipeline. You can now go to Models and see that Model GPT-2 was created. Nice. Let's go back to the designer and click on the fine-tuning component. I'm logging this metric, which tells me that the throughput of this component is 84 training samples per second. This is really good, but I have another fine-tuning component already registered that might do better. Let's try it. I'm going to replace the current component with a new one, reconnect everything, and rerun my pipeline. One thing to notice right away is that my first 2 components are reused. Only the component I replaced and the component that depends on it are rerun. This saves me a ton of time during development. I'm going to skip forward in time once again to the finished pipeline, and I'm going to look at the throughput of this new component. 216 trained samples per second. It's an improvement of more than 150%. How am I getting this speed up? I'm giving you a sneak peek of something Microsoft has been working on, which is still in private preview. It's a new Docker container that brings together a collection of tech that accelerates deep learning training. Now that I have a pipeline that registers my fine-tuned model with Azure ML, I'm going to show you how to deploy that model at scale with a managed endpoint. The first step in deploying a model is to write a score.py file, like the one I'm showing here, that takes in some user input and generates a prediction using the trained model. This file needs to have an init function that Azure ML calls when the endpoint is first created, and a run function that Azure ML calls each time the endpoint is invoked. The code is ready, and now I want to create an Azure ML endpoint so I can deploy this code at scale in the cloud. An endpoint can have multiple deployments. For example, if you want to do A/B testing, you could have some of the traffic go to one deployment and the rest to another. But we're going to keep it simple in this demo and create a single deployment that takes all the traffic. Once again, you have many options to create Azure ML resources. You could use an AZML command in the terminal, or the Azure ML Studio UI. But this time, I'm going to show you how you can use the VS Code extension for Azure ML. I'll go to the Azure icon on the left taskbar and click on the plus sign to create an endpoint, and select Managed Online Endpoint so that Azure manages the compute resources. I'm going to call it Homer Endpoint, and you can give it tags, but I'm going to delete them to focus on the essentials. I'll save this as endpoint.yaml. Great. Next, I need to create a YAML file that configures a deployment within the endpoint. I'm going to click on this plus sign and choose Managed Online Deployment. I'm going to specify the model that we tuned earlier using a pipeline and the location of the score.py file that I just showed you. I'll give it an inference environment that I already registered, a machine type, a name, and the name of the endpoint that we chose in the previous YAML file. I'll remove the scale settings for now. We'll be talking about scaling later. I'm going to add one more setting. I can press Control Space to see all properties available to me. Then I'll start typing, and here's the property I'm looking for, instance count. I'll set it to 2 so the deployment can handle more traffic, and I'll save this file as deployment.yaml. I'll go back to my endpoint file and create the Azure ML resource by right-clicking and selecting Azure ML Execute YAML. If you look in the terminal window, you can see that the VS Code extension automatically runs the right AZML command to create the endpoint. Awesome. Now I'll do the same for the deployment. I'll right-click, select Execute YAML, and the command is executed. This takes a few minutes, so I'm going to fast forward. Okay, the deployment is created. Let's go to the Azure ML Studio. You can see that our endpoint is here, and if we click on it, you can see that it has a deployment called Blue. We want this deployment to handle 100% of the traffic for this endpoint, so let's update the traffic to 100%. We're ready to test the endpoint. We'll go to the test section and type a prompt. This conference is super awesome because I click the test button to see how Homer would have completed the sentence, and we get our result. This conference is super awesome because it is so much more than just a meeting of delegates, the people and their thoughts on pressing issues of our day and age. So true, right? Okay, great. Once you've been running your endpoint for a while, you'll want to know if you're using your compute budget wisely. Let's go back to the Details tab. You can look at metrics for the endpoint here, or you can look at metrics for a particular deployment, which is what we're going to do. I want to visualize CPU memory utilization percentage. I'll zoom into the interesting part. And in the same graph, I also want to visualize CPU utilization percentage. This graph will be useful as my endpoint gets more traffic. To make sure it can handle a lot of traffic, I can change the auto scaling settings. Let's click here, choose Custom Autoscale, then Scale based on a metric, and then add a rule. Here's the rule I want. When CPU utilization is larger than 70%, I want to increase the instance count by 1. I'll add this rule, which shows up here, and I can save it. My endpoint is fully set up now and ready to be used in production. Let's look at the Consume tab to see how we can invoke it. Here you can see the HTTPS address and the key you need to access it. You can now invoke it by doing a simple post request from your app's code. I'm going to show you how you can invoke it using a curl post command in the terminal. Here's the prompt input I'm going to pass to the endpoint. And now I can execute a curl in the command line using the HTTPS address and key you saw in the Azure ML Studio and the JSON file with the prompt. And here's the result. Very cool. It worked. In this demo, I showed you the entire process for turning your data science notebooks into production-ready code. I refactored the notebooks into components, connected them into a pipeline that creates an Azure ML model, and deployed that model using an online managed endpoint. Thank you for watching. And that's all. Okay, so a few things I'd like to say is that I want to kind of call out the announcements in the demo, like the things that are actually new a build. So what you saw, like with endpoints, like being able to deploy a model in the cloud, that's now in general availability, so GA. So it used to be in preview, and now we're actually shipping the feature. So that's new. Components and pipelines are new. They now seem so essential to me that I just don't know how I lived all like last year without actually having access to them. But they're new, and the CLI, like those AZML commands that you saw, those are general availability, a build. And one thing I didn't show here because the previous demo showed is you can also use code to do all of this instead of using the CLI. And that's now preview, a build. So we're announcing preview. There are a couple other things that we announced at build that I don't show in the demo also. One of them is our new responsible AI dashboard, which helps bring responsible AI kind of qualities to your code. So there was also a separate demo for that. And then the other thing we didn't show, but I think is super important, is AutoML, which is a new feature that allows you to say, I want to try these different algorithms to see which one works better for my data, and also which hyperparameters work better for my data. And Azure ML will go and try them all and try all the hyperparameters, and then we'll come back to you and say, you should really be using SVM with these parameters. And that's a really powerful feature because it just saves so much time. And also, the cool thing is that then you have access to the exact code that is generated by AutoML, so you can go change it, you can do anything with it. So it's not like a black box thing, it's totally white box, and you can do anything you want with it that you do normally. So that's it. Those are like the bigger things that we kind of announced at Build and that we're kind of very proud of, and they're just happy to just finally be able to talk about all these things and not just like keep them to myself. So yeah, I just want to know if you guys have any questions or even just hear about your experience. Have you used Azure ML? Has anybody here used Azure ML before? Or is this completely new? Completely new, okay. What are you guys, are you using cognitive services or anything else in the stack, or is that also relatively new to you guys? Also new?
Using cognitive services.
Oh, you are?
Yeah.
Which ones are you using?
Vision.
Vision.
And a little bit of language, but just
Okay.
playing with that. So, yeah, using the Vision one, cognitive services, and tried a bit of the language. Just playing with it more than anything else. But yeah,
very cool. Yeah.
Very powerful.
Yeah,
Yeah,
exactly.
super powerful.
Yeah, usually our recommendation is to go top down, to like look at the top layers and see, does this solve my problem? Like, can I use a no-code solution to do what I want to do? If so, then why write code? And just use that, right? And then you go down. You know, for these two layers, you don't need to be a machine learning expert. You need to be a developer, and you need to know how to write code, but you don't need to be an expert. So if there's a solution here that works for your problem, why go lower? You don't have to, right? Just stop right here. It would just be a waste of time and resources. If none of those work for you and you really need to write a custom model for your problem, then you go all the way down to Azure Machine Learning, and that's basically what I showed. And what it enables is for people that are doing their custom models, they can run them locally and kind of test it all out locally, so without worrying at all about the cloud. But then when they're ready, they can train it in the cloud. Maybe they want to scale their training, maybe they want to add a ton of data to their training, or they want to use a GPU, maybe they don't have access to GPU locally, or a cluster of machines to train. And it also allows them to deploy their model, right? That's kind of what you get with cognitive services. You already get an endpoint that you can just query. But if you're doing it from scratch, then you need to say, okay, now I've trained my model, now I want my model to be accessible behind an endpoint that I can query or that other people can query. So that's basically what Azure ML does. And I think it's very cool. Yeah. Anybody else? Do you want to share your experience, what you're doing, or your interests are? No? All right, then I think we can move on to Ruth. I think we're right on time.
Thank you.
Yeah.
Hi, my name is Ruth Yakubu, and today I'm going to be talking about the Anomaly Detector service that we have as part of our cognitive services. So I don't need to butcher this slide, but B already went through and gave you guys a good overview of what the services are. The area that I'm going to be covering is over here, which is cognitive services. And can you guys guess where Anomaly Detector falls under? Oh, wow. You guys are ahead. Yeah, so Anomaly Detector Anomaly Detector falls under the decision category. So even though you see all of these categories under Anomaly Detector, it doesn't mean that's like under decision. Anomaly Detector is the only service that's in there. For example, there's another one called Personalizer. So there could be a slew of other, cognitive services in there. So that's the category that I'm going to be covering. So to start with, another question, because I'm going to be asking you guys questions throughout. How many of you, if you have the ability to foresee problems before they occur, would be happy? Or would you rather just be surprised by any disaster that comes your way? Yeah. So in general, being able to foresee problems before they occur is essential. And that's where Anomaly Detector comes into picture. Anomaly Detector is used across multiple industries, and this is primarily to help reduce costly incidents from happening, also reduce failures, and failures can fall under multiple categories. Sometimes it's catastrophic. Here's some of the examples. Let's say you have, in health, you have like a medical device, and you're collecting patients' vital signs, diagnostic detection. You could be able to collect data in real time and be able to trigger when something changes. So maybe it's a negative change that somebody needs to act on. Then a major industry that uses Anomaly Detector is the manufacturing industry. As you can see in the picture, that's a manufacturing plant. And a lot of manufacturing plants have multiple sensors. And they're collecting a lot of data in real time. And all of this is to ensure that they are catching problems before they happen. So it triggers preventative maintenance or preventative catastrophes from happening. Let's say something goes wrong, the factory goes down, it's probably going to take a lot of resources and also cost to bring things up. Then another industry that we see anomaly detector being used a lot is in finance. So fraud detection. A lot of you guys invest in stocks, but I doubt you're using that to predict what stocks to, invest in. But this is actually a very good tool. Over time, you can see like behaviors, and sometimes it's not just one factor that contributes to change, because whenever we talk about anomaly detector, a lot of people think it's negative. It could be just change. So something happened, there's change, and you just need to make a decision. So that's, in a nutshell, an introduction of anomaly detector. So when it comes to Azure, what is anomaly detector? So anomaly detection is just another technique under machine learning, and basically what it does is monitor time series data over time, and is able to detect any unusual, abnormal data deviations from the norm. So that's what that is basically doing. So I know in this graph it shows like the data is going down, then it starts going up. We'll go into details into reasons why those two dots are considered anomalous. So one of the things that is a major problem in this sector is detecting anomaly is very challenging. So if you're a company and you're to come up with a model that detects anomaly, it's going to be difficult because number one, we know data is inconsistent, it's constantly changing. That's number one. Number two, with each and every data pattern, there are different machine learning algorithms that you can apply. Then finally, even when you find an anomaly, the question is, what is the root cause? So getting back to the different algorithms that are out there, let's say today your data trend, your data that you collect goes downwards, has this data pattern. So you created an awesome model and you have it out there in production. Then something happens and your data is starting to behave like that. So now you have to retrain your model, and this is like the second model that you have to create. Then if the data changes again, you are constantly changing it. So over time, this is not feasible and it's not sustainable. So those are areas where anomaly detector is very useful. So the question is, when we're dealing with anomaly detection, what type of data do we deal with? The obvious answer is we use time series data. So that's just data that has a timestamp, and for anomaly detector, it's just a timestamp and some kind of numerical value attached to the data. And the data can be coming from devices, can be coming from sensors, it can be coming from websites or your gaming devices, social media logs, and other applications. So in a nutshell, wherever there's data and it's timestamp, you'll be able to use Anomaly Detector. So with Azure, we have different types of anomaly detector model. The very first one is univariate anomaly detector API. So the question is, what makes it, what is Azure's univariate anomaly detector API? It just basically means you have a time series data that just has one metric and a timestamp. And for this API, it comes in two mode. One, you can use batch data. So let's say you have like a database that collected data and you want to find an anomaly in the data, you can use that. You can also use live streaming data as well. So those are the two areas that you use anomaly detection. So remember how I was telling you that if you're working in a workplace and you have to constantly keep up with your model, the good thing about anomaly detector is you take your data input and it automatically, based upon the data that it sees, it automatically selects the best model that is suited for your data. So it's adaptable in real time. It will automatically change. Then, of course, give you the results. Then the next one is the multivariate anomaly detector. And basically, it's what the name says. That's when you have two or more metrics in your data set. And it's also detecting anomalies. So the good thing about anomaly detector, the difference between the univariate API that we have, that one is pre-built. You just plug it in, whatever language SDK that you have, you plug it in with your data, it finds the anomaly. But let's say you have like a unique situation, unique data that you want to train your model. The API also comes with APIs for you to train your custom data based upon your business situation. So it comes with the training API, it comes with the detection for inference, it comes with the results API after you train the model. Okay, you give it data and it's able to bring data back. If you want to export the model, you can also export it into an API. If you want to delete the model, because the good thing about it is almost like experiments. You run as you're training, those are different experiments, and they are having different model IDs. So if you want to delete some of the ones that you decide not to use, you can use that API. Then there's a brand new API that we've introduced, that's the synchronous API. And basically what the synchronous API is, it has two modes. Oh, actually it has one mode. That's for real-time data streaming. So that's for synchronous, when you have like real-time data streaming. The detect is used when you have like a batch data situation. So the use case that we're going to be talking about today for the demo that I'm going to show you is, let's say you have a household and you have like a circuit breaker and you want to detect, okay, what is my energy consumption? every month my bill just skyrockets. How can I pinpoint where the anomaly is coming from? So the good thing is, okay, in the household you have multiple different sources of energy consumptions that are coming in, and you want to figure out, okay, which one is driving the high consumption. It could be, hey, you have like a broken freezer that's working overtime to cool your what's it called, your food, and that's what's spiking the data. So this is an example of if you have like a remote device out there and you want to use anomaly detection. So the question is, how do you get the data to the cloud? So in this situation, we're going to be using IoT Hub. Azure IoT Hub just basically connects devices to the cloud and is able to send and receive data. So we're going to be using that. When you bring in the data, you can store it in a blob storage because it comes as a raw data file. Then you need to format it in such a way that anomaly detection, the Anomaly Detector API is able to recognize the data and the metadata and be able to, do analysis on it. So one thing I also want to point out is when you're dealing with data, you can totally, especially when you're dealing with real-time data, even though I mentioned using IoT device, if you're using Kafka for real-time streaming or you're using Event Hub, there are multiple ways of using the tools that you use for data ingest to be able to pass it along to gather data for anomaly detection. Next thing is programming language. That's a very good thing about cognitive services. We meet you where you're at, so whatever language that you choose to program in, you're able to consume the API. One thing I wanted to point out is the Azure Databricks. That's an example where you have like a huge data lake that you need to process data. So you can use it with different data sources or Azure functions for real life processing or triggering, that sort of thing. Then you can also call the Anomaly Detector API. So I'm not going to go through the, the pre-trained univariate API because that one is pretty straightforward, it's plug and play. But I'll show you how to use the multivariant because this one is customizable. You're able to train the model. So the one thing that's unique about this is, let's say in the household situation that you have data coming from, let's say, the kitchen, your laundry room, all the different rooms that there, all the different sensor data that's gathering, those different data that is coming. So let's say you have power, you're collecting voltage, you're collecting data from the kitchen and all of that. The way it takes the data, you just need a timestamp and a value, and you zip it up. And the key thing is in machine learning, how we label our data when we're about to train it. The name of the file that you actually give your CVS file when you're zipping the whole data is your label. So once you label it into a zip file, we'll show you when with the result, that's actually what your label is going to be. Make sense so far? Okay. So let's go to the fun part and do a quick demo. Okay, I shouldn't say that yet. Okay. So I'm going to skip the part that does the univariate. And basically, to train your model, the very first thing you need to do is, of course, go to the Azure portal. You provision your anomaly detector, what's it called, instance. And the main thing that you need from there is the key, if the browser can respond. So you need the key and the endpoint. So no matter what language that you're dealing with, just grab the key and grab the endpoint, and that's how you're going to be able to interface with the anomaly detector API. So that's basically what we did. This is in Python. All I'm doing is just setting up the environment variables for the endpoint, and also the anomaly detector name and the unique endpoint key. The next thing we're doing is grabbing the data. So your data can be coming from any source. So that one, for this situation, I'm storing in a blob storage, but you can totally be using it in any data source that you have. But for me, I grabbed the information from the IoT hub and routed it to the blob storage. And once it's in the blob storage, I'm just telling it, okay, go to the blob storage and grab the data. Yeah, so this is the zip file where I put all the files in, and I'm saving it to the blob storage. Next thing is, when we're training our data, normally we partition the data and say this percentage is going to go to training, this percentage is going to go to testing. But in anomaly detection, you can partition by the timestamp. So you can say from this timestamp to that timestamp, use it for training. So that's basically what I'm doing here. The next thing is basically defining a class. And you can do this in any language. All I'm doing is I have the API key, I have the endpoint, and I have the data source. Then I'm creating a class with all of these different fields. Then within the class, I'm using the SDK. The very first thing I'm going to define is a function that does the training. So using the SDK, you're able to, you have the client that you instantiate, so you just bring the client in. I'm specifying where my model, the data is. I'm also specifying loading the data into the model class. The next thing is, this is a HTTP call to the API, and the API is going to give you a result. So I'm just parsing the part that would give me the model ID. Then the rest is just running. When you're running, it has different state. It can be ready, it can be processing. There are different modes that it goes through. So all I'm doing is checking, is it ready yet, is it ready yet? After it's trained, it's going to return a model. The next function is same, use the SDK. And now that I have an API model, I'm ready to infer the, what's it called? The model. I need the model ID. I need a timestamp that I want to do the testing. So you give it the timestamp range and call the what's it called? The SDK to actually do the inference. So give it the data, the timestamp, then yeah, call it the get method that actually brings the results back. And this will be different for in any language. And with all of this, it also gives status. So when you're invoking all of these APIs, it's good to monitor the different states that is telling you whether it's done processing or not. The export field is pretty much straightforward. Create a function and use the client for the SDK to export your model. You give it the model ID. Then this is the part that I'm actually doing the model inference, giving it a timestamp. So I'm calling the train after I define the, what's it called? The time range. I call the class with the train method, and it returns model ID. Then I'm actually doing the inference after the training. And if you notice, I'm also calling the API that returns result ID. And with the result ID, that's how you go and grab the data from the anomaly detection. So what I'm doing is just printing out the ID and the result that came from inferring the model. Then the very last thing I'm doing is you actually need the result ID to actually look at your data. So everything stays the same. You're using your keys and whatnot. And in order to get your results, I'm calling the API with the URL that is defined out here to get the results. So once you have the results, then you're ready to do what you want with the data. In my case, I'm gonna display the results. So all of this is just, as you can see, is drawing. I'm just configuring how the plot should look like. But basically from the data that I collected the meter reading for the kitchen, the laundry room, the power of the voltage. Those were the 4 different fields. And in real life, you can have, let's say you're in a factory, you can have like 200 different sensors. But all of those will be like different files that you just zip it up. There's nothing special, it's just a timestamp and a value. So the results are gonna give you these critical information. Given the time range that I gave it, this is the behavior that we're seeing in real time. And it's also notifying where it saw an anomaly. So one thing about multivariate is it's not just finding that an anomaly happens. The key thing it does is also find a correlation, because there's a relationship in when something goes wrong. So let's say, okay, Let's use this room for example. Let's say I crank up the heater to like 300 degrees. We're all going to be sweating, right? So that's a correlation. So just think of it. Wrong analogy, not so perfect analogy, but just think of it like that. So it all goes back to finding root causes, and also the severity controls how granular you want the anomaly to be. And I'll get back and show you guys the significance of granularity. So this is an example of just one timestamp, the output. So if you have the results, it could be like thousands of, depending on your data, is like thousands of records of JSON. But how to read this is, for each timestamp, it's going to tell you whether or not an anomaly happened, the severity, then the score. Then there's a field called interpretation. So the main thing it's showing is, look at the contribution score. This is what your root cause is. So for all of the different data points, what it does is the one that has the highest contribution score, you know that's what caused it. So in our case, that would be the temperature that I cranked up. Then, okay, what are the correlations? What was the domino effect that affected this? So the kitchen and the laundry room. And as you can see the values also change. So you can compare the different values that change over time as you're going and analyzing the different points out there. So that's what basically anomaly detection does. Let me get back to the slides. Yeah, so we talked about visualization. Everything is about relationship, correlation, is doing all of this for you. You created a model once, and it's able to give you an anomaly. One final thing, the severity actually is what controls whether an anomaly has happened. So with anomaly detection, this is a time series data. As it's reading it, it's not just looking at your data, it's also predicting what the next data point is. So if I'm at timestamp at 4 p.m., it's predicting what 4:01 or the next timestamp is going to be. So it predicts ahead of time. Then if you notice there are boundaries, upper and lower boundaries, the severity that I mentioned earlier is what controls the thickness of your boundaries. So you get to control how granular you want to capture your anomalies. So for this one, if you notice, anything that falls within the boundary is not going to be considered an anomaly. But anything that goes outside of the boundary is what's going to be considered an anomaly. So if you notice that one was out, that one was in. So that's in the back of anomaly detection. That's what's going on. So this was just a high-level introduction of anomaly detection. We have a Learn module. I suggest taking a picture of this And it actually has exercises. So with this one, you actually go through like the real life data with what's it called, univariate, and you see in real time how the data is changing and how it's detecting anomalies in real time. The next thing is you can use the data that is provided to train your own, to train the model, but I highly suggest that after you finish the learn module, use your own data to play around with it and be able to save your cost and reduce any disasters from happening. Thank you.
I have a question. Thank you. So I have a question about the format of the data that you need to supply the service with, like because it needs to have timestamps, and each file for each variable needs to have the values for that variable.
Yeah.
Is there a predefined format that you need because it's two pieces of data? What they look like in the file?
So that's the beauty of the Learn module. It actually shows you all of that, but that's a very good question because the format of the data for univariate is going to be different from the multivariate. For the univariate, you need to tell it there's a field called granularity. So it tells you how often your data is going to be. So is it minutely? Is it hourly? Is it weekly? Is it monthly? Is it yearly? That sort of thing. And it has, if you say it's minutely, it has to be every minute. There can be no gaps, or it's not going to work. Or if you're in a real life situation, figure out how to fill in the gaps, but that can potentially skew your numbers. Then the next thing that you also need to specify is the max ratio of anomalies that you want. So it's like a ratio. All of that is covered in the course, but let's say there are going to be anomalies. You just say, okay, give me the top 10%. So that's like the max ratio that you can specify. Then this whole upper and lower boundary, we go into real details to really understand how that's calculated and how that is predicted. So you can see that in real time. Does that answer your question?
Thank you.
Yeah, and it will show you the JSON format that you need, but that's a complex, I'll say that's the most semi-complex part. With multivariate, all you need is the CVS file is just going to have a timestamp, comma, value, or multiple values. Any other question?
I have one actually. Once you've trained the model, can you take the model and move it further down the pipe? So in an IoT scenario, have the anomaly detection done at the edge rather than actually having to send the data to cloud to be detected?
I wish I can give you a prize.
So what I'm thinking is, like, you do it at the edge, that way we don't need to send all the data every second, every minute, every hour. It just, actually, now there's a problem, we'll send the data up and send it then. Is that?
Yeah. Actually, that is the ideal way of using this anomaly detection. Using it to actually taking that model, deploying into the edge. But we have something called Onyx runtime. So that is actually going to accelerate your runtime. So yeah, you can take a model like any other model, plug it in. It's going to run on the edge, but to get like very fast performance, I'll suggest looking up Onyx runtime, and we also have that on the Microsoft Docs. and that's ideal for the edge. But this is just a precursor to just show you what's possible. But realistically, in real life, that's how our customers are using it on the edge.
Cool. Perfect. Thank you.
Yeah. That's it.
Alrighty, okay, we'll start. So my name is Dave Glover, and I'm one of the members in the AI team, in the cloud advocacy team. And I've traditionally had quite a focus on IoT, and that's kind of morphed into the world of AI on the edge, and amongst other things. So this is what this session is going to be about, is running machine learning models on edge devices. And specifically, we're actually going to be talking about Azure Sphere, but really it is applicable to a wide range of single board computers, such as Raspberry Pis or Arduinos or things like that. If you want to take a screenshot or if you want to take a photo, there's a link here, aka.ms/predictive maintenance. And on that link, you will find, in fact, I'm just going to bring up the website. This is actually my GitHub. My GitHub's super easy to remember. My name's Dave Glover, and everything lives on glove boxes. So that's where you'll find me on GitHub. And you'll find a lot of projects up on there. And this particular solution is documented up there, complete with a little 10-minute teaser. And on the wiki, you will find complete information about how to go and set it up, how to go and create all the developer tools, how to go and set up IoT Central, how to go and set up logic apps, and integrate that with Teams. So the complete documentation for this project is sitting up on GitHub at that link. So just going back to the slides, and these slides are basically, I've nicked the images off that blog, off that GitHub. So that's where, so you'll find way more detail on the blog, on my GitHub. I keep saying blog. Alrighty, I'm also from Australia, so if you're wondering what the funny accent is, it's a kind of a combination of Australian, English, and Kiwi. And I am allergic to wearing long trousers, if you might have noticed. So apologies for a glare off my legs, and my head too, for that matter. Alrighty, so what we're going to talk about is the goals for this project. So this is really around predictive maintenance, and the whole idea behind predictive maintenance is really trying to be able to identify a problem kind of in its infancy. So detecting a problem before it becomes a real issue and becomes super expensive in terms of just fixing, or downtime for machines and things like that. So the typical kind of environment for this would be what we call industrial IoT, or AIoT. Those are kind of the categories that this comes under. And the project, the kind of scope for this, or the goals for this project, were around security. So we want to make sure that the device that we're going to be running is tamper-proof, so it can't be hacked. The other goals are really around operational efficiency, and that kind of comes under a whole range of things. It could be under ensuring that when someone goes out to service a particular device that needs to be like an HVAC system, and a heating, ventilation, air conditioning system, when someone goes out and repairs it, they kind of get a sense of what they might need to go and do to go and repair. Is this a bearing kind of issue, or is it a frame or a suspension issue, or types of things? And those types of things can be picked up by the way the model was trained. So if the model was trained to detect a broken bearing and a fan maybe it's just starting to wobble, you can train the model for that, or you could train the model for suspension or springs or whatever it might be. So what that does, it gives you a lot more information as to might be what is wrong with the machine. So when you go out there, you kind of go out there with the right information. The other focus for this project was around sustainability. And I know everyone talks about sustainability at the moment. And it's kind of driven a lot of my thinking of recent as well, in terms of a lot of talk around climate change and things like that. So sustainability can come under a wide range of categories. It can come under corporate sustainability, or human sustainability, environment, power usage, and things like that. So this was mostly around, excuse me, if you think about human sustainability, it's like sending the right people out only when you need to send them out. And that obviously reduces resources, reduces time, people costs, all those types of things where this might be appropriate. Environmental. So environmental, I think I probably particularly had power usage in this from a green perspective, is that these models will run on ultra-low powered devices. So ultra-low, typically ARM-based CPUs, which are running at a much slower clock speed, and they just consume less power. And then what you'll find inside this project is just some general ideas around what you can do to reduce power consumption. So because you've got a model which you can use for inference on the data that's coming into the model, you can start making smarter decisions about this device. So for example, you might want to say, well, look, most of the time, there's nothing really that interesting happening. In which case, I might turn off the network, I might turn off the Wi-Fi, or turn off a screen. And if you're familiar with devices, you'll know that things like Wi-Fi and screens, they're by far the biggest consumer of power for these devices. So you can start making smart decisions about the actual consumption of energy for these devices based on the output from that model. And of course, for these scenarios, most of the time, 99.9% of the time, it's actually very uninteresting data that they're looking at. You're just saying, it's business as usual, the fan or the HVAC system or the lathe or whatever it is, it's kind of running normally. So it's kind of very uninteresting. And just most of the time, it's just not worth firing up other parts of the device to actually transmit data when there's nothing ready to be done. Now, the question comes up around AI on the edge versus AI in the cloud. And the analogy that I really like is just our own nervous system. So if you think about, we have the peripheral nervous system and we have our central nervous system. And I'm sure we all did it as a child. We were told not to touch something that was hot. And what do? We go and touch something that's hot. And of course, what happens? Our hand immediately jerks back. And if you followed along with you paid attention in at school, you would have realized that that is the peripheral nervous system and what's called the reflex arc. And the whole idea behind that is it's responding very quickly to external stimuli. In this case, it realizes that there's something hot. And what's happening is that's being processed in your spine. It's not going all the way up into your brain. And it's being processed and it causes a twitch to pull back. And it's a very similar analogy with if you've got industrial equipment where you need to be able to respond really quickly to be able to stimulus. And you don't want to send a message up to the cloud because by the time the message gets up to the cloud, you run it against a model in the cloud. I don't know why I'm pointing up there, but I always do. And then you send a message back down to the device. And then they say, okay, it's time to switch off. And if you're running like a lathe, which might be spinning at thousands of revolutions per minute, if you wait for a couple of seconds, that could be the difference between potentially hundreds of thousands of dollars versus being able to shut the thing down and get it repaired quickly. So that's the kind of the idea. So if you think about the peripheral nervous system can make local decisions, and then what happens? A message will eventually send to your brain where you go, ouch. And that's kind of what we happen. That's the kind of the architecture for running models on the edge, where you've got local inference, be able to make decisions on it. There's business as usual, keep ignoring. Then suddenly something happens. You want to be able to respond locally, shut down the machine, and then ultimately what you want to be able to do is send a message to the cloud system to say, there's been an issue with this device. So that's the kind of the logic behind when you think about do you go and put something in the cloud or do you put it on the edge? So that kind of comes down to what we call latency. So you do need to be able to respond really quickly. Now, the other reasons why you might go and put AI on the edge come down to the value of data and the volume of data. So in this scenario, let's say you're monitoring a lathe, you might be monitoring it multiple times per second. Let's say it's 5, 10 times per second. It is generally completely unrealistic to be able to send that volume of data up to the cloud, to the cloud systems, and then have that processed and analyzed and run through a model. So again, those are some rationales where it gets cost prohibitive to go and send out all the data to the cloud systems. And most of the time, the data is of extremely low value. And it just makes no point to be able to send that data into back-end cloud systems. So those are kind of rationales. So you're dealing with high volumes of low-value data, makes a lot of sense to go and run it on the edge, and where latency is super important. You want to be able to respond to this thing really quickly. So those are kind of the rationales. When you're thinking about is my data from my devices, is it once an hour, once a day, whatever it is, then sure, that makes a lot more sense to go and maybe run it on a container, in a factory somewhere, or send it to cloud systems. But if you need to be able to respond super quickly, then it makes way more sense to go and put it on the edge. Okay, so what I'm going to talk about now, this solution lives and breathes on something called Azure Sphere. Now, I know a few folk here know about Azure Sphere. Now, this solution is by no means limited to Azure Sphere. This is the platform that I chose to use. It's Microsoft's secure IoT system, operating system, and it's made up of kind of three components. It's made up of certified microcontroller, which is a multi-core microcontroller, which I'll talk a bit more in a moment. It's made up of an operating system. It's actually a hardened version of Linux, and it's been highly tuned for small devices. So to kind of give you an idea, it runs in probably around about 4 megabytes of memory, of which half of that is kept free for updates. So we do things like over-the-air updates. So it runs in a really small environment. It's POSIX compliant, and it's been geared for highly secure devices. And in fact, if you really want to delve into it a bit more, go search for the 7 properties of highly secure devices, and it'll talk through what is considered by the industry to be highly secure. So things like hardware root of trust. So things like an unforgeable ID on that, so you know that device is that device. Certificate management. You get rid of passwords, certificates that are refreshed on an hourly basis to make sure that someone's not hacking into those things. But there's a whole range of things, including over-the-air update. So for over-the-air update, that includes both the application, but of course the model. So invariably models will need to be updated over a period of time, and there's a way in which you can distribute out these models out to these devices. So that's kind of the general rationale behind these things. Now, I'm not going to dwell on this too much, but this is kind of the architecture of an Azure Sphere. So the main thing out of this is it's what's called a multi-core microcontroller. It's also known, you'll see it in the reference, as a crossover microcontroller. So it's a crossover between an application device and what you might also consider to be kind of traditional microcontroller devices. So it has a couple of what are called Cortex M4s, and they are there for running real-time applications. Now, in this case, what I'm going to be doing is I'm going to be running a TinyML or TensorFlow Lite. Also, both kind of used interchangeably. I'm going to be running a TensorFlow Lite model on one of these real-time cores. Now, also the beauty of this is that these are completely isolated. So they're not exposed to the network, and they're very difficult. In fact, nothing's near enough impossible, but incredibly difficult to be able to break in and actually change something. So they're a highly secure environment. So you've got these cores that can run these machine learning models. You've got 2 cores for real time, so you could run multiple models. You could run 2 models on these devices. And you've also got what's called a high-level core. And a high-level core is where we run the Linux, basically run the Linux operating system. And you can go and put in custom applications, and they're the applications which can talk to cloud-based systems. They tend to be less timing sensitive. So what we've got running on these real-time cores is the model, and the data is time series data which is generated from an accelerometer. So there's basically an X, Y, Z. So it just picks up to say, okay, is this device shaking? And that time series data has been fed into the model to make the prediction that it's a bearing or it's a vibration or whatever it might be that the model has been trained around. So that's kind of where these things run. Just to really emphasize, they are geared towards low power consumption, and you can really power back the amount of energy that you use on these devices. Now, the device that I've got here, which I'm going to demo in a moment, in fact, I shouldn't wiggle it too much, otherwise I'll break my demo. I won't break the demo, I'll just trigger the demo. So I'm using an AVNet board. If you're not familiar with AVNet, they're a company, they make components, electronic components. In this case here, they've built a developer board. You can see the device sitting over here. I can't get my mouse on it. I can point, can't I? This device here is actually the Azure Sphere module. It's pre-certified and it's put onto these developer boards. A developer board is really for prototyping. They're not the things to go into production. But the important thing about this board is it has an accelerometer on it. So it's built-in sensor, it has built-in temperature, pressure and humidity, has built-in light sensors, but most importantly, it's got a gyroscope, and most importantly, it's got an accelerometer. And it's the accelerometer that I'm going to be using for this. And then to kind of go around the actual application architecture. So as I mentioned, there are a couple of real-time cores. They're real-time in red because they're fast. So we've got 2 models that are running. Now, really important to emphasize here, we're running inference. We're not training any models on these devices. They're not, you'd be there forever trying to train something. It's purely about doing inference and prediction. So we've got 2 real-time cores, and on one of the cores, I'm going to be running a movement classification prediction model. So that's kind of what's going on there. And on the high-level core, it's all around security, it's around trust, update services, and it runs what's called a high-level application, and it's responsible really for communication, secure communication with the outside world. In this case, to IoT Hub or IoT Central. So in terms of how this solution kind of looks end to end, so I've actually used something called Edge Impulse. Now, it's not a Microsoft offering. It's a third-party offering. And what it's about, it's for being able to build machine learning models that are specifically targeted for microcontrollers. That's kind of their world. And if you go into it, you'll see that pretty much all the microcontrollers that really exist in industrial, or exist for industrial or for hobbies or whatever, are pretty much covered within the list of devices. The other thing about Edge Impulse, it's built for people like me. And people like me are software developers. I'm not fundamentally a machine learning data scientist person. I'm a developer first, who kind of has a basic idea or has a reasonable understanding about machine learning. So it's very much a developer-focused offering that you go in there and they've got a free tier and you can go and effectively what you do is in this case here I have an Azure Sphere, and I would get a stream of data out of that thing, in which case I'd say, okay, I'm going to put the device I'm going to make the device vibrate. And I'm going to take the stream of data that comes off the accelerometer and then feed that into Edge Impulse. And then you'll see that there's basically a wizard which you go through to train up these models. And then ultimately at the end of it, you get through that and there's a way in which you can go and test the model and deploy the model and things like that. And ultimately what I've done is exported that model out of Impulse Edge. And I've exported as a C library, which I've basically done a little bit of wrapping around, and to go and deploy it as a real-time application running on Azure Sphere. So that's kind of the way it works. So I've got this model now that's I've exported out of Edge Impulse, and I've exported that onto the Azure Sphere device, and then there's a cloud service behind that, and you go and say, look, you upload the application, and then there is a cadence by which that application will be deployed down to the device. And again, if you make updates to the model, again, that will be deployed down to the device. So as I said before, that's responsible for communications and running the models and inference. Now, this device is actually going to be talking to IoT Central. Now, if you're not familiar with IoT Central, it's a low-code, no-code IoT portal. And it enables you to go and really define what we call models. There are different types of models. There are what's called a plug-and-play model, which describes the type of data and the interactions between a device in a JSON document. And that basically it gets uploaded into IoT Central, the device connects, the device says, hey, I'm the predictive maintenance, I want the predictive maintenance IoT plug-and-play model. It goes and grabs it from a repository, and voila, you've got your application and your forms and things like that. And then what you can do is you can actually export that data out of IoT Central, and there are multiple ways in which you can export that data. So you can export it out into Event Hub, you could export it out into storage, blob storage, and you can export the data out to a webhook. And what I'm going to be doing is exporting this data out to a webhook. And the webhook is actually been implemented using Azure Logic Apps. So again, low code, no code, pretty much drag and drop. You go and describe the schema of the data that's coming out of IoT Central, and then you just basically map that. So okay, here comes an endpoint. You've got an HTTP endpoint. The data comes in, and in which case I'm going to feed that data into a Teams connector. And then you can describe the message that you want to go and put into Teams. And so that's kind of where this is going. Now, would you necessarily in production go and push this into Teams? Maybe yes, maybe no. You'd probably go and push it into production system. But it kind of gives you the idea of how you can see this data flowing through the system and using using low code and no code. By the way, does anyone have any questions? Feel free to fire away if you're online or anything. Okay, so that's kind of the solution. All the way from building the model in Edge Impulse to exporting it, running that inference on the edge, and flowing that data through IoT Central and Logic Apps. Alrighty, so what I'm going to do is we're going to go for a little bit of a demo. And some parts are going to be quite light, I will confess. So what I'm in here is Edge Impulse. And I've set up a new project and I'm using the free instance in this case. And they have some really common scenarios. So the first one here is around, I want to go and build a model out of accelerometer data. It's a super common thing to do. If you think about predictive maintenance in the world of industrial IoT, I'm guessing that predictive maintenance is probably 60 to 70% of the market. I think that's a big part of the scenarios that get used for these types of things. So accelerometer data makes complete sense to have that there as one of the scenarios. And you literally go click on it, which I won't do quite a moment yet, and you can do that. You can also do things like wake up words, like, we've all got watches or phones, hey Siri, hey Google. You can go and train wake up words and say, look, I want this device to respond to whatever it might be. You can go and define that. You can also go and define models and build models for images. And doing local image analysis and classification. And the other option there is for something else. Now, I'm not going to go through the whole process, but I can promise you it's very much around a wizard. It takes you through this whole process, really well documented. Their documentation is just fabulous. If I go into here around creating an accelerometer, you can say here, connect your developer board. And I'm not going to connect it here because I've already trained the model. But if you live in the world of microcontrollers, you will appreciate that's pretty much, I think it was like 90% of the market is covered. From the kind of entry-level kind of ESP32 devices to Raspberry Pis to Azure Spheres to STM devices, they're all pretty much covered there. So that's the dashboard there. In fact, I'll just quit out of here, and you can see that they've also got opportunity to go and retrain the models and go and test the models and stuff like that, model testing and things like that. So they kind of got that whole life cycle of building models. Okay, so the next thing I'm going to show is IoT Central. So remember I said that data is going to go from this device, it's detected something's happened, and I'm going to ship that device to IoT Central. Now it would take you for a whirlwind tour around IoT Central. I've got devices over here, and one of the ones I've got, and I'm just showing you this because it's got more data than the predictive maintenance solution. And hopefully this will come up in a moment. I should have warmed it up first. Okay, there we go. And I think that device is running back home. And what I think it's doing, no, it wasn't. It was a bad luck one to choose. Trying to remember which one's running which now. Now look at that. Anyway, the ones I'm choosing have no data in them at the moment. They're not connected. But you've also got things like, whoops, we'll just go back into, where am I going to go? That's super funny, they've renamed it. Here we are, Data Explorer. They haven't renamed it, it's just me. And what I can do here, damn it, so it's not going to have oh no, I can expand it. So we've got time series analytics in here. And you can see that there has been a lot of data flowing into this system, and you can kind of zoom into data. So it's basically an implementation of time series data. So as I said, it's a low-code, no-code portal by which you can have data flowing into the system, and you can do reporting and things like that. What I'm going to do is, you remember I said that data is going to come through, and I'm going to be exporting this data. And what I can do is I can set up destinations, and you'll see I've got here a predictive maintenance logic app. And what I've set up here is a webhook, and this is the URL of the webhook, the Azure, of the Azure Logic app. So it's a webhook in this case. So that's defining the endpoint of where this data is going to land. And if I come back to destinations and I go to exporting, and I go into predictive maintenance, and here you can go and define criteria for the data. So you've got the data coming in, and you might be interested in things like contact names. If I'm going to raise a fault, a contact name would be kind of useful. Maybe the device description, the location, things like that. That kind of information can flow through. And then ultimately, what you can do is you can export it to an endpoint, or in this case, to a webhook. And the webhook that I'm going to send it off to is that destination I just showed you a moment ago, called predictive maintenance. Okay, so if I come back up here to devices, and I've got a predictive maintenance application and device hooked up. In this case, this device that's sitting on the desk here, I've named it Reactor HVAC System. And we can go into here and we can look at what's going on. And we can see that the last known state was that this device, this HVAC system, had a rattle. And you can see in this case I've defined the contact name, number, location, and what the device is. So you can get, this is device, this is information that's both reported from the device as well as metadata that you can define in the cloud. Okay, so that's pretty much where I was going for that. Okay, so what I've got here is I've got an Azure Sphere device which is hooked up, and as I said, it's got an accelerometer, and I'm going to do some kind of funny gestures. And because this has got the accelerometer in it, I kind of trained it like this. I think this one is the ball bearing predictive model, and that came out for Anomaly. If I shake it side to side, this will be hopefully the rattle gesture. And you'll see what's going on in a moment that we get. So if you can see, it's probably a little bit too small. Well, let me just make that a bit bigger. Alrighty, so you can see up here, this was the last prediction that came from the model. And again, so I'm sure if I do this, I'll get various. It has about 5 states that it can determine. Okay, it's just come up with an anomaly, which is just fine too. And I'm just going to do a rattle. And that data will come through. Okay, so what's happened there is that data is coming to IoT Central, and you remember I'm doing a data export, and I'm exporting it out to a Logic app. So if I come across into the Azure portal, and I've got the Logic app set up here already, and I've got an HTTP endpoint, and what I've got here is a schema which describes the data that will come in from IoT Central. And you can see in here, I've got application ID, I've got things like device ID, which is type string. If I scroll down a bit further, I've got what are called enrichments. I've got the contact name. Somewhere down here, this was the fault prediction, which is of type string, and things like that. And then ultimately what this data is going to be then forwarded onto is a module called post message to a chat. And if I scroll this down, you can see what I can do now is I can I've created this Teams connector, and I can take that data that's come through in that schema. So I've got knowledge of what that data looks like, and then I can map it into a message. So in this case here, I can say, look, this is a Teams message, which is going to be, it's going to be an HVAC maintenance alert. And it's a fault prediction, and you can see that I'm mapping that into the fault prediction schema that I have. I can say that the HVAC ID is, the description, contact name, contact number, location, etc. And then magically, I have, and then what that would do is it'll execute when I get that webhook gets called. And if I come down to Teams, you'll see that at 8:03, if you can see that, I don't think I can make this much bigger actually. You'll see that 8:03 p.m., there goes my alert, and you can see, so it's 8:04 now, so the last thing was a rattle, which was up on the IoT Central port, and you can see that this data's come through. So it provides a really neat solution by which you can take, run that model, get it up into IoT Central, get that data, moving that data through into Logic Apps and then into Teams Connector. And the beauty of it is it really is very little code. There is a fair amount of code you need to think about or worry about on the device, but once you get that data into the cloud, there's actually, you can start using low code, no code solutions to kind of fill out the overall solution. So that's pretty much the demo. So any questions behind that? Okay, cool. All right, so I think just in kind of summary. So I mentioned Edge Impulse, so that's what I've used to go and build the model. And you remember I'm running inference on the edge device here. And that's pretty much the talk. So the complete documentation you'll find up at aka.ms/predictive maintenance. And you'll find all the code up there and all the documentation to step you all the way through building a solution from the device all the way through until getting that message popping out in Teams. Cool. So thank you very much. Great. Any questions online or?
Online, no questions. If anyone has a question, I have the microphone here.
Are there any leftover M4 cores for real-time control?
Yes, there are. So so the question was, are there any other cores? So that the microcontroller that's used on Azure Sphere for the Generation 1 devices is actually a 5-core device, of which 3 of them are there for custom applications. So I was running the predictive maintenance, the movement classification engine on just one of those cores, and I could equally go and run another real-time application on one of the other cores. And they can talk to each other, and they can talk to high-level cores, and they can do all those types of things. So yes, you can go and run more than one real-time application on a device.
Great.
Yep. Cool. Alrighty. On to the panel discussion.
Yes, we will kind of do some redecorating here, and we will be back in like 5 minutes for the panel. So hi everyone, and welcome back to the A Bit of AI live from Redmond. So now we're going to record a live recording actually of the A Bit of AI show. So 5, 4, 3, 2, 1. Hi everyone, and welcome to the A Bit of AI show. My name is Henk Boelman, cloud advocate at Microsoft. And I'm a white male with brown hair, wearing glasses. And today I'm wearing actually a very brand new Reactor t-shirt. The A Bit of AI show is all about the people behind the AI jobs, behind the AI systems. Like, what do they actually do during the day? What type of roles are there in AI? And how did the people get to this point in their career for this particular job? And today is a very special episode because I'm finally together with my 3 colleagues here in Redmond, in Seattle. So we're going to find out what they did to actually get to this point in career and being a cloud advocate focusing on AI. So I want to start with like a quick round of introductions. So Dave, can you introduce yourself?
Alrighty, so my name's Dave Glover, and AI cloud advocate. I'm based in Sydney, Australia. And how much more do you need? So yeah, you can follow me on D Glover on Twitter. Yep, do for now.
Hi, my name is Ruth Yakubu. I'm based out of New York. I'm also on the AI and ML cloud advocacy team.
And hello, my name is Stollnitz, and I'm on the same team as these 3 people. This is the team. This is the advocacy AIML team, and I'm based in Seattle.
Cool. So first question for you, B. Can you explain what a cloud advocate is?
Sure. There are 3 pillars to cloud advocacy. They help us guide what we do in our job. So there's a pillar that relates to community, so doing things like this, either video recorded or in person. where we talk to to users, Microsoft, or even potential users, to developers. We talk to developers about Microsoft technologies. Another pillar is content, so we produce content, whether it's articles or video or whatever that may be, that can help people learn more about certain technologies that we use at Microsoft or that we create at Microsoft. And then the third pillar would be product. So we partner with product teams and we help them understand their users, and by being a user ourselves, like an early user of the product, but also by bringing back feedback from the field to the product team, so that they can better direct how they should create their products. And so those are basically the three pillars that guide everything we do. And then the other thing that I would mention is we're not salespeople. We don't talk to customers, so we're basically more developers who talk to other developers, and usually in a one-to-many kind of capacity.
And what do you think is the favorite part of the job for you?
For me, it's product. I think that was pretty clear in our conversations today. I really love helping to shape the product. I love partnering with the product team and kind of help guide the product, like being an early user and complain a lot about it. No, and just essentially, look at it from a potential developer's perspective, like from an outsider's perspective, and kind of help the team understand where the pitfalls are and how can they make things better.
And you get to play with all the shiny new stuff.
I do. That's another huge advantage, that I generally play with stuff before there's documentation for that stuff. So, and I just really love being on the cutting edge like that, like playing with things before they're out there. Yeah.
Thank you so much for sharing that. So now that's basically what we all do. So Dave, what is your favorite part of the job?
Okay, so my favorite part of the job, I was thinking as you're speaking, so we've as you've got these three pillars. One of the things that I love is just a general passion for technology. So if people are looking at these types of roles, if you're really interested in technology and particularly where the technology is going, then this job is just the perfect job. If you like to kind of come up with some crazy ideas, and some of the projects I work on are definitely in the crazy area, but I kind of view them as kind of inspirational products. So you might be able to look at this idea and think, well, maybe I'd never do that, but maybe that will trigger an idea to say, well, actually, this is a potential solution to a business problem, because ultimately that's what we're trying to create products that do. But it's come up with something that's inspirational and to trigger people's thinking into, heck, I could do that, and this might solve a real world problem. So those are the kind of things I like to think about.
Excellent. Go for it. And Ruth, what is your what project are you working on now?
So the area that I'm really excited about is around responsible AI. The company is built on the products that we actually built in-house. We really take the principles of responsible AI very seriously.
What are those principles?
That's a good question. So, for example, fairness. When you're creating an AI solution, there's a checklist of things you should consider before and after you're building a model. There's transparency. Depending on the model, the industry that you're in. Some industries are heavily audited, so you should be able to show transparency. And even within your team, if your superior comes and asks you, okay, you claim this model is very accurate, how do you prove that? Then there are other areas like accountability, and privacy is a very huge thing that every organization or every individual has to be aware of. So protecting customer data and also protecting data while you're training your models, that's very important. Then safety and reliability, they kind of go hand in hand. So the question is, what am I working on?
Yes.
Yeah, so I'm very excited because for the longest time, Microsoft is known to be one of the leaders in the industry for adapting responsible AI. We talk about the principles on how we're doing things in-house, but since, like my colleagues mentioned, we reach out to developers. So the question is, how do we empower you to build the same solutions? So we're bringing to you tools that you can utilize from A to Z and be able to incorporate that into your solution. So we had build, was it last week or 2 weeks ago?
Last week, yeah.
Well, time flies. But we introduced the Responsible AI dashboard, and it's able to show you things like explainability. So when you're analyzing your model after it's done, to explain, okay, what are the key features that led to your model prediction, or going deeper into your model and seeing, okay, what, like the disparities. So let's say if you're a loan company and you're using historical data, it could be that I liked one of an example that somebody used. Let's say a single mom goes for a loan, she's probably denied a loan, as opposed to maybe somebody who's, like a family that's a spouse, husband and wife, that sort of thing. So the question is that are you being accurate, or are you discriminating against a certain group? So those
Is
are
that what a responsible AI dashboard can kind of show you?
Yeah, it can show you all of that. And also another thing that I think is very cool is also tools that Microsoft has been partnering with Harvard and some of the industry leaders in terms of how can we tackle privacy. So as you're building these models, let's say you're analyzing the model. We're using different data when we're training our model. So the question is, how can you introduce noise while you're training the model to keep the data secure? And when you're analyzing the model, so let's say we're in a hospital situation and we're looking at the data. Some of the data, somebody who is malice that is potentially probing into the data can put 1 and 2 together and it's like, yeah, that sounds like Henk, that sort of thing.
We don't want that.
Yeah, we don't.
So you're saying basically by adding a lot of noise into the data, it gets more anonymized.
Exactly. And another area is the noise, but also you have to also take into consideration we deal with synthetic data, GANs data. So how do we handle situations like that? So it's a deeper area, but the good thing is that's what we're going to be working on. We just announced it last week. So we're going to be bringing it to the masses and teaching developers how to incorporate that, because we're so used to building models end to end and deploying, but we don't do a good job in terms of almost like DevOps, in terms of having a team that is actually testing these models and making sure are they truly a good quality. Yeah, so, and it's very
interesting.
Yeah, it's very what's it called? I won't say it's very easy to use, and I think developers will really appreciate that.
I think so too. You showed me a preview, and I and I liked it. So, the Bit of AI show is all about like learning and getting to know how people learn. So in our job, we have to learn constantly new things, and I think responsible AI is a new thing you have been learning over the past months, I guess.
Yeah.
So what is your approach in learning something completely new?
Oh my God, I can't believe you asked me that. So my personality, I've always asked why. So I'm very curious. So I love getting my hands dirty and learning new things. So one thing that is very cool about working for a large company like Microsoft, where we have a lot of AI products and services that are very cutting edges. You get to learn what is on the brink of innovation and be one of the first to like get your hands on it, similar to what B was talking about, working with the product team. So it's very exciting when we get those, and also we're extra excited, like, oh, we can't wait to share with the developer community.
So you basically kind of learn by grabbing the product and trying things out and see what it does?
Yeah. And yeah, just seeing, oh yeah, and another thing is, it's not just seeing how it does, but thinking of, okay, a normal person that's working at a job, how can they apply this in a real life situation? So it's not just thinking one aspect. I'll say, let's say, form recognizer.
Yeah.
Not to just think of form recognizer, but think of end-to-end scenarios that somebody can use in real life. And it helps developers open their mind of the possibilities of incorporating a solution into, the AI product and service into their solution.
Excellent. Thank you so much for sharing. Dave.
All right.
It's you.
It's me.
Yes. So I have a new question for you.
Can I
Oh,
answer the question you had before? There's a couple of things I want to kind of add on that one.
Okay.
So the question came up about how do you learn? And I just want to give a bit of my experience because I've come from perhaps a different angle. So I've predominantly been a developer. And I'll just kind of give you a bit of an idea where I went down the path to AI, because to me, AI was kind of like a bit of magic that was sort of happening over there somewhere. So some of the practical things that I went and did, you'll find a stack of online content, obviously. And what I did is I went and did a Coursera. There was a Coursera course that I went and did, which kind of went back to the maths behind it. And my maths was pretty rusty by this stage. But for me to actually go back and learn some fundamentals around the maths behind machine learning, I found invaluable. I've actually now pretty much forgotten that maths, but that doesn't matter. And that it's taught me enough to now have a conversation about AI. The other things that I've done that I found really useful is meetups. So in Sydney, there is a machine learning meetup. And I would just go along to those and just sit down and listen to what people are talking about. They kind of industry experts are standing up there and talking about it. And I found that invaluable for myself. So if you're in a situation where you're kind of starting and figuring out where to go, there is almost certainly a meetup in your local area. And my strong recommendation is you just sign yourself up, take yourself down there, go and have some bad pizza, and go and learn about machine learning. For me, that was invaluable, and it connects you with people who can also help you. Again, the other things that I did kind of on my journey is I go and look at, we've got somebody from NVIDIA here, so they have a lot of content about machine learning. So I started looking at what the folks at NVIDIA were doing around particularly things like, what's the small device? Jetson, thank you. The Jetson. I looked at running these models on things like Jetsons. And then obviously Microsoft Learn content. And I would just go through that content. And in fact, I have got a mountain of content to still go through. And B has foolishly offered to talk me through some of that content. But those are the kinds of things that I did around learning. So I like to just kind of get my hands dirty, as Ruth was saying. There's a stack of content on the internet. Go look around. If courses suit you, then go and find Coursera, or there's a whole stack of these places, and get yourself involved with meetups and learn from other people and contribute into those communities. So that's kind of what I've done.
You want to add something to that, Bea?
Sure. I'll actually, a lot of what was said here applies to me also. But one thing that motivates me to learn is to teach. If I have like in my mind that I'm going to explain, I need to explain this to somebody else, then I'm going to be so much more motivated to learn it. So to me, that's a really big driver with learning. And so in grad school, it was being a TA. It was like absolutely the highlight for me of being in grad school was to teach, because then I had all this motivation to go learn. When I was learning machine learning at first, I just decided that I was going to teach my husband something every day. And so I would just like read throughout the day or in the evening or whenever, and then like for dinner, I would explain to him something, right? And that was very cool because then he learned machine learning too. So now what happens a lot in my job is I'm learning something and I think I want to blog about it so that everybody else can learn. And so that's kind of my motivator to go learn it deeper.
Thank you. I think that gave like a really good introduction about how you learn and all the different types of ways you can learn. So we always end the show with kind of a lightning round questions. And Bea, you've been in the show, so
I have. They're hard.
They're not hard.
They are.
No,
Go for it.
Cool. So it is a lightning round question, so you don't have to explain your answer. You might, because some answers are could be very interesting. So we start with one question, and we will go from Bea to Ruth and back to them. That saves handing over the microphone.
Okay.
So Bea, the last programming language you used?
Python.
C.
Java for Onyx.
Java. Oh, interesting. Cool. So then we start with Bea again.
That's not fair.
I know.
It is.
The next thing you're going to learn?
Onyx.
Ooh, the next thing I'm going to learn. I'm going to learn more about Azure machine learning. Tomorrow. That is what I'm going to learn about. Yep. And then I think I've got a stack of reading to do after that.
I'm going to learn more about smart noise.
Nice. So keep it. You can keep it, Ruth.
Okay.
Okay. So then one question to get to know you like a little bit better. So what was your first computer?
What was my first computer?
Yes.
It was a Dell computer from work.
Okay, we secretly trying to get your age.
I knew that. That's why I was like, a Dell computer from
So what
work.
operating system was it running on?
It was on Windows. So does that put me in Forever 21?
It's good. We all move to Dave. Maybe.
All right. Okay, so this is going to give my age away, definitely. So I think my first computer was, and I must admit, I think I had some sort of gadget probably from birth, some sort of a computing device. I think it was either the Sinclair Spectrum Z81 or something along those lines. This is really going back to the dim dark ages, and some folk might be saying, "I remember that," and I must admit, I wished I'd kept mine. Anyway, I didn't. And the other one was the BBC Micro, and that was a device that came out eons ago. It had, I seem to remember, it had the ability to be able to play multiple tones at once. That was very advanced, and of course we all rushed to it. And it had a tape, so I think they had a TOS, so a tape operating system. And you would load, you press the record button, and you'd save your program onto the tape, and you'd press play, and it would play the tape back onto the device. So anybody else had something similar? Similar? Yep. Okay. So maybe a few of us are showing our age, but that was definitely a device.
So I have an older brother, which really helps being around computers since I was born. And so I remember the little computers, which I didn't even know what they were, that he used to build from kits. But the one I really remember was actually the Spectrum, was it Z or ZX81? Z81, something like that. Because it was the first color computer that we had. So I remember my brother bringing it in, putting it together, because it also came in a kit, and then plugging it into a color TV, and there were 16 colors. Pretty amazing. That made an impression on me.
Cool. So we're going to leave it with that for the show today. So thank you so much for joining us in the show. Thank you all for watching, and I think we can find everyone on social media if you have more questions for any of our advocates. So thank you so much for watching, and we will be back in a few weeks.
Thank you very much.
Thanks for having us.
Sinclair had a lot to answer for, didn't he?
I know. We're like advertising.